Continuing Learning Workbook, page 138, we will now solve some ALEX problems. Suppose p of x equals negative 2x subtract 4, and q of x equals 2x plus 4. Find p composed with q of 1, and q composed with p of 1. Okay, so this is really two problems in one. Let's just focus on the first part right now. All right, let's rewrite this using the definition. P composed with q of 1 is equal to p of q of 1. And because this input is a number, we will work from the inside out. That means the first thing I need to figure out is, what is q of 1? Let's do that in our side workspace. We know that q of x is equal to 2x plus 4. Therefore, q of 1 equals 2 times 1 plus 4. Both of those ones need to be in parentheses. This one because that's how functions are written, and this one because this x has a multiplier. We need the parentheses to indicate that multiplication. Now we can simplify. 2 times 1 is 2, 2 plus 4 is 6, so we get q of 1 equals 6. Again, that's the same thing that we were looking for over here. We were trying to find the value of q of 1. We now know that that is equal to the number 6. The things around it do not change. So now we have to find p of 6. We will also do this in our side workspace. We know that p of x is equal to negative 2x subtract 4. Therefore, p of 6 is equal to negative 2 times 6 subtract 4. Okay, let's simplify. Negative 2 times 6 is negative 12. Negative 12 subtract 4 is negative 16. So p of 6 is equal to negative 16. This is the answer to this question. You can write your answer as just a negative 16 in a box, or you can write p composed with q of 1 equals negative 16. Okay, now we're going to move on to the second part of this question. But before we do, let's take our answer to the first part and just write it down here in this box in the corner. And then when we're done, we're going to compare and see if these give us the same values. Okay, here we go. All right, so now we want to find q composed with p of 1. So let's go ahead and do that by rewriting this using the definition. This is q of p of 1. And because this is a number, we work from the inside out. So the first thing we need to figure out is, what is p of 1? Let's do that in our side workspace. We know that p of x is equal to negative 2x subtract 4. Therefore, p of 1 is equal to negative 2 times 1 subtract 4. Simplifying by following order of operations, this gives us negative 2 subtract 4, which is negative 6. So p of 1 equals negative 6. This thing that we're trying to find out, what is it equal to, p of 1, is the same as just the number negative 6. So let's replace that big green box with a negative 6. Everything else around it stays the same. Now we need to find what is q of negative 6. And again, we'll do that in our side workspace. We know that q of x equals 2x plus 4. Therefore, q of negative 6 equals 2 times negative 6 plus 4. Following order of operations once more, we get negative 12 plus 4, which is negative 8. So q of negative 6 equals negative 8. So this q of negative 6 equals negative 8. So our final answer for this question is q composed with p of 1 equals negative 8. Both ways of writing this final answer are acceptable. Now, before we call this one problem done, there's something that I want everyone to notice. P composed with q of 1 gave us the answer negative 16, but q composed with p of 1 gave us the answer negative 8. Those values are different. What that means is swapping the order in which you compose two functions matters. It changes the answer. Okay, let's do another Alex problem. All right, suppose we have two functions, p of x and q of x, and p of x equals x squared plus 1, while q of x equals the principal square root of the sum x plus 6. Find the following: p composed with q of 3, and q composed with p of 3. Okay, let's start with the first one. Let's rewrite this using our definition. This is the same thing as p of q of 3. The input is a number, and therefore we work from the inside out. We need to figure out what is q of 3. We'll do that in our side workspace. We know that q of x for this problem is equal to the principal square root of the sum x plus 6. Replacing every x with a 3 tells me that q of 3 is equal to the principal square root of the sum 3 plus 6. Notice that I do not have any parentheses on this 3, because this x does not have an exponent, does not have a multiplier, and is not being subtracted. Now we simplify. 3 plus 6 is 9, and the square root of 9 is 3. So q of 3 equals 3. It's just a coincidence that these numbers are the same. Usually, when an input number goes into a function, a different number comes out. So, q of 3, which is what we were looking for over here, can be replaced with simply the number 3. The rest of the problem is unchanged. Now we need to find what is p of 3. And again, we'll work in our side workspace. We know that p of x for this problem is equal to x squared plus 1. Replacing every x with a 3, we get that p of 3 is equal to 3 squared plus 1. Notice that I must put this 3 in parentheses because this x has an exponent. Simplify. 3 squared is 9. 9 plus 1 is 10. So p of 3 equals 10. We're trying to find what does p of 3 equal. P of 3 equals 10. So the answer to this problem is 10. You could also write p composed with q of 3 equals 10. Both are acceptable final responses for a problem like this one. Okay, now let's reverse the order of our composition. And this time we're going to do q composed with p of 3 and see if we get the same answer or a different answer. Okay. So this would be rewritten using the definition as q of p of 3. And because this is a number, we're going to work from the inside out. So we need to find what is p of 3. So we go to our side workspace. We know that p of x is equal to x squared plus 1. So p of 3 is equal to 3 squared plus 1. We did this just a moment ago. So this is 9 plus 1, which is 10. P of 3 equals 10. So this right here is just a giant 10. The things around it stay the same. Now I need to find out what is Q of 10. Let's go to our side workspace. Q of x is equal to the square root of x plus 6. Replacing each one of these x's with a 10 tells me that Q of 10 is equal to the principal square root of the sum, 10 plus 6. Just as before, no parentheses needed for this 10. So we get the square root of 16, which is 4. So Q of 10 equals 4. Q of 10 is what we were trying to find, so we get 4. So our final answer for this problem is 4. Q composed with P of 3 equals 4.